Visualize this. You're standing at the edge of cosmic understanding, and suddenly, two of humanity's most powerful telescopes deliver news that obliterates the very foundation of everything we thought we knew about our universe. The Webb and Hubble space telescopes have just confirmed something absolutely mind-shattering, something that's sending violent shockwaves through the scientific community right now. What if everything we believed about how fast our universe is expanding was not just wrong, but catastrophically and dangerously misunderstood? What if the very numbers that define our cosmic reality are revealing a story we never anticipated? Today, we're diving deep into a discovery that's torching textbooks and forcing astronomers to question decades of established science. This isn't just another space story. This investigation is about the fundamental nature of reality itself crumbling before our eyes, and why the universe might be expanding faster than we ever imagined possible. Let me start with something that should terrify and electrify you at the same time. For years, scientists have been measuring how quickly our universe is expanding using different methods. Think of it like trying to measure the same distance with two different rulers, expecting to get the same answer. Except, here's the nightmare that's been keeping cosmologists awake at night. Those rulers keep giving us wildly different measurements. The first method uses something called the cosmic microwave background. This is essentially the ghostly afterglow of the Big Bang, radiation that's been screaming through space for over 13 billion years. When scientists analyze this ancient light, they can calculate how fast the universe was expanding in its violent birth moments. This method presents us one number for what's called the Hubble constant, the rate of universal expansion. But then there's the second method, and this is where things get absolutely insane. Astronomers look at distant supernovas, these apocalyptic stellar explosions that shine with predictable brightness. By comparing how bright these cosmic bombs should be versus how bright they appear to us, scientists can calculate how fast the universe is expanding right now. This method gives us an entirely different number. Now here's where the Webb and Hubble telescopes come into play, and why their recent confirmation is detonating shockwaves through the scientific community. For years, some scientists desperately hoped that maybe Hubble's measurements were slightly off, that perhaps there were small errors in the data that could explain this discrepancy. With its revolutionary infrared superpowers and unprecedented precision, the Webb telescope was expected to definitively resolve this debate. Instead, Webb has confirmed what Hubble found. The measurements are brutally accurate. The universe really is expanding at two different rates, depending on how you measure it, and nobody has a clue why. This confirmation creates what scientists call the Hubble Tension, and it's not just a minor disagreement between measurements. We're talking about a fundamental crisis in our understanding of cosmic physics. It's like discovering that the speed of light changes depending on whether you measure it on Monday or Tuesday. It absolutely shouldn't happen, but the data says it's happening anyway. Think about what this revelation means for a moment. Every model we've built about how the universe works, every prediction about its future, every calculation about dark matter and dark energy, all of it depends on understanding how rapidly space itself is expanding. If our measurements don't agree, then something profoundly disturbing about our cosmic picture is wrong. But wait, because it gets even more reality-bending. The Webb Telescope hasn't just confirmed the Hubble tension. It's also discovered something else that's making astronomers question their sanity about cosmic expansion. The telescope has been peering deeper into space and further back in time than ever before, and what it's finding is demolishing our most basic assumptions about how the universe evolved. Webb has detected galaxies that formed impossibly early, galaxies that are far more massive and mature than our models predict. These ancient cosmic structures are shouting at us that the early universe was a completely more alien place than we imagined. Star formation happened at breakneck speed, galaxies grew larger sooner, and the whole timeline of cosmic evolution might need to be completely rewritten. The collaboration between Webb and Hubble on this discovery is particularly remarkable. These two telescopes operate in entirely different ways. Hubble primarily observes invisible light, the same light our eyes can see. Webb conducts observations in the infrared spectrum, identifying heat signatures and light distorted by the universe's expansion. We cannot dismiss these findings as instrumental errors or observational biases, given that both telescopes consistently report results about the expansion rate. The implications extend far beyond the mere measurement of cosmic expansion. If the Hubble constant really does have different values, depending on how and when you measure it, then our entire framework for understanding dark energy might be completely shattered. Dark energy is the mysterious phantom force that's supposedly accelerating the universe's expansion, making up about 70% of everything that exists. But if expansion rates are changing in ways we don't understand, dark energy may not be what we think. Some scientists are now proposing radical, mind-bending solutions to explain these observations. Maybe there's revolutionary new physics we haven't discovered yet. Perhaps there are additional types of matter or energy that we can't even detect with current instruments. Some theories suggest that the properties of space itself might be morphing over cosmic time, causing expansion rates to vary in ways that our current models can't even begin to account for. Others are wondering if we need to fundamentally demolish and rebuild how we measure cosmic distances. Maybe there are systematic errors in our methods that we haven't even identified yet. Or perhaps the universe is infinitely more complex than our simplified models assume, with local variations in expansion rate that average out to different values depending on which cosmic neighborhood you're observing. The scientific community is responding to these challenges in absolutely fascinating ways. New theoretical frameworks are being frantically developed to explain the observations. Alternative theories of gravity are being desperately reconsidered. Some researchers are even questioning whether our understanding of basic physics needs complete revision on cosmic scales. What makes this discovery particularly earth-shattering is its timing. We're living in a golden age of astronomical observation, with instruments like Webb and Hubble providing unprecedented detail about the cosmos. At the same time, we're facing fundamental questions about the nature of reality itself. The combination of better data and deeper mysteries is catapulting science into uncharted territory. The confirmation of universe expansion rate discrepancies also underscores the extent of our unexplored knowledge about our cosmic home. Despite decades of observations and theoretical work, the universe continues to blindside us. Every answer seems to give rise to new questions, and each solved mystery paves the way for even deeper puzzles. For those of us watching from Earth, these discoveries remind us that we're part of something infinitely more complex and dynamic than we ever imagined. The universe isn't just expanding, it's expanding in ways that obliterate our most sophisticated theories and demand revolutionary new ways of thinking about reality itself. As Webb and Hubble continue their observations, we can expect more bombshells, more confirmations of unexpected phenomena, and more reasons to question everything we thought we knew about our cosmic assumptions. The universe, it seems, still has countless secrets to reveal, and we're just beginning to understand how staggeringly little we actually know about the cosmic stage on which our entire existence plays out. The collaboration between these two remarkable telescopes represents humanity's relentless quest to understand our place in the cosmos, even when that understanding forces us to confront the terrifying limits of our knowledge and the mysteries that remain buried in the vast darkness of space.